RAM is computer main memory in which specific contents can be accessed, read or written, directly by the central processing unit in a very short time regardless of the sequence, and hence location, in which they were recorded. Two types of memory are possible with random access circuits, static RAM, SRAM, and dynamic RAM, DRAM. A single memory chip is made up of several million memory cells. In a SRAM chip, each memory cell stores a binary digit, 1 or 0, for as long as power is supplied. In a DRAM chip, the charge on individual memory cells must be refreshed periodically in order to retain data. Because it has fewer components, DRAM requires less chip area than SRAM. Hence, a DRAM chip can hold more memory, though its access time is slower. Without your computer being able to store and access data quickly, none of your apps or other processes would work. That's where your RAM comes in. But what is RAM exactly and how does it work? Keep reading to learn what RAM means, why it's so important for smooth, fast processing, and how to optimize your computer's RAM with specialized performance software. RAM, Random Access Memory, is a computer's short-term memory, where the data that the processor is currently using is stored. Your computer can access RAM memory much faster than data on a hard disk, SSD, or other long-term storage device, which is why RAM capacity is critical for system performance. RAM stands for Random Access Memory, and it's one of the most fundamental elements of computing. RAM is a temporary memory bank where your computer stores data it needs to retrieve quickly. RAM keeps data easily accessible so your processor can quickly find it without having to go into long-term storage to complete immediate processing tasks. Every computing device has RAM, whether it's a desktop computer, running Windows, Mac OS, or Linux, a tablet or smartphone, running Android or iOS, or even an IoT computing device, like a smart TV. Nearly all computers have a way of storing information for longer-term access, too. But the memory needed to run the process you're currently working on is stored and accessed in your computer's RAM. RAM is a form of temporary storage that gets wiped when you turn your computer off. RAM offers lightning-fast data access, which makes it ideal for the processes, apps, and programs your computer is actively working on, such as the data needed to surf the internet through your web browser. To understand RAM, let's use the analogy of a physical desk. Your working space is the top of the desk. That's where you keep everything you frequently use within arm's reach, so you won't waste time searching through your drawers. By contrast, anything you don't use that much or that you want to save for later goes into a desk drawer. On your computer, your RAM is like the top of your desk, where you keep everything you need quick access to. And the data that you don't use much or want to save for later is stored on a hard disk, either locally in your device or in the cloud. RAM is used for immediate data storage and retrieval. Your RAM can process information significantly faster than data on a hard disk, 20 to 100 times faster, depending on the specific hardware and task. To accomplish a specific task, computer operating systems load data from the hard disk into RAM to process it. When it's finished actively working with that data, the computer converts it back into long-term storage. When you open a program such as Microsoft Word, your computer loads the application into its RAM. If you open a document you already have saved on your computer, your operating system locates the file in long-term storage and copies the information onto its RAM. Once the data is in your RAM, you get near instantaneous performance because RAM is lightning fast. When you save a document, or any other type of file, the data gets copied to the hard disk or other long-term storage. And when you close an application, the computer operating system takes it out of its RAM, which frees up space in your computer's short-term memory so you can work on your next project. If you forget to save a document to your hard drive and the power fails, all that work is gone, because the purpose of RAM is temporary storage. Another use for RAM is to help your computer load previously accessed information more quickly. When you first turn on your computer and launch any application, such as PowerPoint or Spotify, it takes a while to load. but if you close a program and then relaunch it, the software opens almost instantly, especially if your PC is optimized for performance. That's because the data needed to load the app is stored in the significantly faster RAM rather than the hard disk. In short, RAM is used for any task that requires quick access to computing resources. A Windows feature called Superfetch helps make this access even faster and more seamless, by recording your usage patterns and automatically preloading applications and files into RAM based on your behavior. The more RAM your computer has, the faster it runs. If your device is old, you might need to upgrade the RAM or other hardware. Every open application, including browser tabs, consumes RAM. When you run out of RAM, your computer has to move things around to free up space on the hard disk, which slows down your computer. Note that RAM is different from storage. If you turn off your PC, the information in your RAM is gone, but the data saved in your long-term storage, SSD or HDD, is saved. The amount of RAM you need depends on the apps and programs you use, how many of them you have open at the same time, and how impatient you are. We always want our devices to respond instantly to our commands, so if you notice sluggish performance, check your RAM and other PC specs and make sure that you're not overtaxing your computer. Usually, you need far less RAM than you do hard disk space. Again, think of that physical desk at home. The more space you have on the desktop, the more pieces of paper you can spread around. But you may still need a big filing cabinet to store all the files you've collected over time. Back in the days when hardware was based on Pentium CPUs, you rarely needed more than 8 megabytes of RAM, perhaps 32 megabytes if you were a serious tech geek. When you buy a computer, you have several options of RAM capacity: 4 GB, 8 GB, 16 GB, or even more memory, 32 GB, 64 GB, if you use high-end editing software or are an enthusiastic gamer. Lower-end or legacy devices usually come with 4 GB of RAM, while higher-end, and more expensive, machines have 8 GB or 16 GB of RAM. And you can find professional-level computers with even more RAM. But how much RAM do you really need and for what? Here are our recommendations, which apply to any operating system or personal computer hardware. 4 GB of RAM, if you use your computer to browse the web, work with standard office applications, and do light photo editing, you'll be fine with 4 GB of RAM. 8 GB of RAM, heavy multitaskers or light gamers should choose a computer with 8 GB of RAM. 16 plus GB of RAM, some tasks are computing intensive, such as serious gaming, video editing, programming, or having to run multiple intensive tasks simultaneously. Those who demand professional level performance with no slowdowns will need 16 plus GB of RAM. What happens when you don't have enough RAM? How do you know? When the computing tasks exceed the current amount of memory on your computer, the operating system has to choose an application and move it to the hard drive. When you switch back to that application, it needs to retrieve that information before you can work with it. This is called paging or swapping, and it's time-consuming. The process causes delays and performance drops. There are multiple types of RAM. As with other forms of computer hardware, scientists are always trying to decrease energy consumption while increasing speed and capacity. RAM has been around since the first days of computing, and in early microcomputing eras it required enthusiasts to plug in chips one at a time. Things have come a long way since then. If you're struggling with low PC performance, or if your computer has only 4 GB of RAM or less, the best way to improve computing speed without buying a new machine is to free up your available RAM. There is a ways to get more RAM without upgrading your RAM cartridges. Close active programs. Any browser tabs you have open, especially in Chrome, or applications you're running consume RAM. So if you don't need a tab open or aren't actively using an app, close it. Only launch what you actually use. Random access memory is a form of electronic computer memory that can be read and changed in any order, typically used to store working data and machine code. 1. A random access memory device allows data items to be read or written in almost the same amount of time irrespective of the physical location of data inside the memory, in contrast with other direct access data storage media, such as hard disks, CD-RWS, DVD-RWS, and the older magnetic tapes and drum memory, where the time required to read and write data items varies significantly depending on their physical locations on the recording medium, due to mechanical limitations such as media rotation speeds and arm movement. RAM contains multiplexing and demultiplexing circuitry, to connect the data lines to the address storage for reading or writing the entry. Usually more than one bit of storage is accessed by the same address, and RAM devices often have multiple data lines and are said to be 8-bit or 16-bit, etc. devices. In today's technology, random access memory takes the form of integrated circuit, IC, chips with MOS, metal, oxide, semiconductor, memory cells. RAM is normally associated with volatile types of memory where stored information is lost if power is removed. The two main types of volatile random access semiconductor memory are static random access memory, SRAM, and dynamic random access memory, DRAM. Non-volatile RAM has also been developed, and other types of non-volatile memories allow random access for read operations, but either do not allow write operations or have other kinds of limitations on them. These include most types of ROM and a type of flash memory called NOR flash. Use of semiconductor RAM dated back to 1965, when IBM introduced the monolithic, single-chip, 16-bit SP95 SRAM chip for their System/360 Model 95 computer, and Toshiba used discrete DRAM memory cells for its 180-bit Toscal BC1411 electronic calculator, both based on bipolar transistors. While it offered higher speeds than magnetic core memory, bipolar DRAM could not compete with the lower price of the then dominant magnetic core memory. MOS memory, based on MOS transistors, was developed in the late 1960s, and was the basis for all early commercial semiconductor memory. The first commercial DRAM IC chip, the 1K Intel 1103, was introduced in October 1970. Synchronous Dynamic Random Access Memory, SDRAM, later debuted with the Samsung KM48SL2000 chip in 1992. Thank you for watching this video.